Hi, Leonardo. Let's go to analyze the equation of a plane. There is two approach. The first approach of a plane, to define a plane, is a vector approach. It yields to a parametric equations. And the second approach, it leads to a Cartesian equation. Okay, let's go to realize what it means to have a plane. If you have a plane like this one, you see this plane, you have a point in the plane. The point in the plane is P0, that is denoted by the point x0, y0, and zeta0. Now, if you have a plane, you have the set of points that pass for 3 points that are not collinear. The 3 points may be Q and R. So let's go to put Q here. Let's go to put Q here, Q and R. And for sure you know how to find PQ. And for sure you know how to find PR. And for sure you know how to find U in the direction of PQ. The unitary vector in the direction of PQ is U. And for sure you know how to find PR and the vector V. The vector V is the unitary vector. Let's go to put it here. The cap is the unitary vector in the direction of PR. So V is in the direction, is unitary vector in the direction of PR, and U is a unitary vector in the direction of PQ. Okay, so the vector approach, the first approach say that a plane is defined by any point x. Let's go to erase here. Let's go to erase here to see it clear. Any point x, this point x, this point x, this point x, you can imagine the vector r that goes from the origin to the point x. Okay, this vector. You can imagine the vector that goes from the origin to the point r0, p0, or p. What is the vector r? The vector r is this one, is this vector, the vector r of any point x, y, z in the plane is made as the vector r0 plus a linear combination of 3 times u maybe plus 5 times v. What it says this is that you can arrive to any point x by changing the alpha and the beta. The alpha is the t that we use in the previous equation of the rectilinear line, but I like to naming as a alpha and beta instead of t and w maybe. Okay, so the first approach say you can arrive to this point x on the plane, you can arrive to this point by adding r0, this vector, and a linear combination of u and v. You adjust the alpha and the beta to be convenient to arrive to the point x. So a plane is defined by this equation. This is a parametric equation. Of course, you can write the r like xi plus yj plus zeta k. R is xy plus yj plus zeta k. The r0 is x0 I plus y0 j plus zeta 0 k plus alpha times u. U is u1 alpha times u. u1 I plus U2 J plus U3K plus beta times V, V1I plus V2J plus V3K. Okay, this is the first approach. Let's go to the second approach. The second approach says, if you can find the normal vector n, this normal vector, the one that is perpendicular to the plane, oh, how I will find the normal vector? You make the cross product of two vectors in the plane. So you do the cross product of PQ, the vector PQ, with the vector PR. And the cross product is the normal vector. So what it says that the second approach, what it says, the normal vector n dot product a vector that is on the plane. A vector that is on the plane is R minus RP. R minus RP, let's see here, R minus RP is this vector, is this one. Let me put it. Let me write it. R minus RP is this vector. This is the vector R minus RP. And this vector lie on the plane, is sitting down on the plane. So the dot product of n with this vector, R minus RP, R is generic, is 0 because they are perpendicular. So the second equation is that n dot R minus RP is equal 0. Or in other words, R is xi, so it will be x minus x0, and 1 by, let's go to write it, n is the vector n1i plus n2j plus n3k. Dot product. The vector r minus r0, x minus x0, I plus y minus y0, j plus c minus theta 0 k. And these have to be 0 because they are perpendicular. So this rule defines a plane. And if you do the dot product, you will have this equation. If you do I by I is 1. I by j is 0 because they are perpendicular. I by k is 0. So you will have n1 x minus x0 and 2y minus y0. And this is the equation of a plane. Now let's go to the equation of a plane in an example. Okay, let's go to an do an example. Let's say that the 3 points that we are going to choose is P is 1, 0, 0, so it's this one. Q is 0, 1, 0, it is this one, and R is 0, 0, 1, which is this one. And the plane is here. The equation of the plane is what we want to find. The equation of this plane. So OP is the vector that goes from O to P, is this vector, the red one. OQ is this vector, and OR is this vector. Okay, first step, find PQ. Find the vector that goes from P to Q. Let's go to put it in green, this vector, and find the vector that goes from P to R, this vector. Well, if you find, you will achieve this result. Second step, find the normal. How you will find the normal? Do PQ cross PR. If you do it, you will find that the normal vector is this vector. And the step 3 is impose the condition that the normal vector multiplied by any vector that is on the surface of the plane. He's sleeping in the surface of the plane. And what is any vector that he is sleeping on the surface of the plane is R minus R0. R minus R0 is on the plane. And R is a generic vector. The generic vector is X xi plus yj plus zeta k. So the normal vector, I have it, is 1, 1, 1. And r minus r0 will be x minus x0. x0 is the point P. X minus 1, y minus 0, zeta minus 0. And the dot product, you multiply components through components, and you sum. So you make the multiplication 1 by x minus 1, 1 by y minus 0, 1 by zeta minus 0. Zeta minus 0 is zeta, so you arrive to this equation. You rearrange the equation and you will have that x plus y plus z equal 1. So the equation of the plane is this one. We found the equation of the plane. Now we need to be sure that we did it correctly. If you put the point P, is the point P on this plane? Oh, easy. Put the x 1, put the y 0, put the zeta 0, sum 1 plus 0 plus 0, 1. Oh, yes, it's true. Is the point Q 0, 1, 0 on the plane? Yes, 0 plus 1 plus 0 is 1, And the point R, same, is on the plane. And what other point is on the plane? For example, the point 1 plus 1 half minus 3 half. The point x equal 1, y equal 1, zeta equal minus 3 half. Is on the plane? No, because 1 plus 1 half is 3 half. So I will put it here 3 half, so minus 1 half. This is on the plane because the sum will be 1. So the point 1, 1 minus 1 half, the sum, 1, 1 half minus 1 half. This point is also on the plane because the sum, it will be 1. And the point x equal 1 half, y equal 1, and zeta equal minus 1 half is on the plane because the sum is 1. Okay, and you can find many points, of course, infinity number of points. I hope it will be useful. Now,